Hello. Okay, I was muted here. We need to check for my volumes, right? Um, okay, why my audio is duplicated? Hey, hello, hello. This is so strange. Hello, 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 hello. I see that probably it's on your desktop. What is happening? Hey, it's duplicated, right? Let's see here. It seems to be okay. It's my, it's the Spotify. Let's see with the Spotify sound. Where is Spotify music? I turned it on. I turned it on. Let's play now. Yeah, it was just too low. Let's level up a little. It seems to be okay now. Not duplicated, right? Yeah, the bug has gone. Don't know why exactly. Okay, so let's today. I'm adjust some things here on BS. My hardware encode just stopped working, and now I can't encode the string with the with the old settings, and that means that the string can become a little unstable. But let's see what's gonna happen. I'm hoping that I can just live stream without problems today. I will open here the live monitor for that. Seems to be stable now. Yeah. So let's begin our day. I'm missing a little with with my scheduling to do the study, because last few days was the last day we had a holiday here. No, it's a world holiday, but here in Brazil it's like the day for that. Check that. It's called finados. Don't know if other countries had it too. To be doesn't have oh no, here. So we have something like for English. Also say. So we had yesterday also it's November 2, so everyone has this holiday. And the Monday I have a little busy, so could not stream that day. But I will really to finish this chapter very fast, because I really want to try something with the knowledge we have to now. I want to at least to reach the effect monad thing, at least, because I have seen a lot of examples of effect system, right? Mainly with the front end things. And I feel that it's very important to put that, right? And that applicative validation, I don't know about that. Yes, probably it's good to understand that too, because I feel that is a very used thing, right? I feel that's related to that do and ado keywords, right? So yeah, we must pass to both chapters before we begin to build something. So yeah, we are very close to finish that chapter here. We finish. Let's see here. We finished the dedupe thing here. Yeah, we finished that thing here. And we have read I remember that I had been this block of exercise here to solve them. So let's try to do that very fast. I really want to finish that. First exercise, define a partial function, use unsafe maximum, which is a partial function which finds the maximum of non-empty array of integers. Define a partial function's unsafe maximum. Remember that partial function here, right? It's like having a function that has not that not handle all possible values from the given arguments, right? So like I can handle in this function an array int that has like specific values inside of that array, but not for ordered case or like for an empty array, right? So we can do that, allowing partial function in PureScript, and it's gonna throw at runtime in JavaScript, right? So it's just gonna crash if we call the function with that side or that specific unhandled case, right? I'm curious about how that is handled by like Haskell language, right? Because Haskell language don't have a runtime, right? So what's gonna happen with that? I feel that probably it's gonna just crash the program, right? Like in dumping something, just crash and dumping some, I don't know, strange error. Let's see here, partial function. Partial functions. Yeah, that is partial functions in Haskell too. Usually, if you have a partial function, it's because you type something and should fix that rather than rewriting partial function, which is impossible. A good example of that is head. You should not use the function. I was really looking for. I want to check if sorry, let's back in. A good example of that is head. We have seen that. The problem is in type it says which can most find other function concern. Why? Because you might have an empty list. Instead, more honest type lets you write another function. Would be a, maybe a. This makes the possibility of not getting a result. Oh yeah, right. I must have an access for a partial function. Those are methods. Yeah, but not resolve my question. What happens when you call partial function? When you call, who calls today, right? I'm receiving a spam call in my cell phone. What happens when you call a partial function without handling not handled in Haskell? I'm curious about that. It's probably exception, right? Not exception, Haskell probably don't have that. Let me ask that for someone here. Yeah, I should do that in Haskell community, not in PureScript community. Maybe that is a Haskell community. Let's check here in Google. I can of course ask that in PureScript, like what happens if you call a party function in a backend that have not a runtime. Yeah, it's not the case in PureScript because every backend PureScript backend is actually a runtime, right? Let's ask that. Handle that. Is that right? Handle that. Let's see here. It's the past of handle, right? Yeah. Also, then what happens if someone calls a function? So now oh, sorry. What happens in that is not a runtime? Let's see if it's. I need to check here. defines a partial function unsafe maximum partial array int. It finds the number of a non-empty array of integers. Test out your function in PSCI using unsafe partial. Use the maximum function for data foldable. Define a partial function safe maximum, which finds the maximum of no empty array of integers. The maximum of a non-empty array of integers. Test out your function in PSCI using safe partial. Use the maximum function foldable. The maximum of a non-empty array of integers. Test out your function using safe partial. Use the maximum function. So let's check that maximum function first, right? It's in data foldable. Data foldable, and to recap, data foldable is something we have seen that before. Yeah, foldable is a type class which represents data structures which can be folded. Fold array folds the structure from the right, fold L from the left, fold map folds the structure by accumulating values in a monoid. The fold implementation are provided by following functions. Some combinators of the default implementations are unsafe to use together, causing a non-terminating recursive cycle. This combination of documented perfection for that function. So we have some instance. It means that all those guys here can be like folded, right? Array can be folded. These operations here can be folded. Okay. So defines a partial function. Use safe maximum because yeah. Let's back here to the maximum thing. What is it? It's somewhere here. Search for that here. So find the largest element of a structure according to its order instance. So we have another type class here. So we have some instance. It means that all those. I was just checking the sound. It seems to be okay. I'm joining here now. Yeah, let's move that for here. Oh, nice. Function from server programming for everything you need to know. Popularize system programming with your Rust. One things related to programming checkout helps student learning. Let's join TypeScript community too. Because you know. Please refrain from using Boolean besides English. No spell. Harassment threads. Person use it correctly. Follow the score toss. Step out the common sense. Keep language safety. Avoid this. Functional programming. How much members have here? Can I know that? I don't know.
I'm sorry if you're having trouble toning up. That's why I made you this show. Because in my opinion, falling asleep is one of the best feelings there is.
I need to mute that because I not to be overwhelmed with notifications. And let's see here, low level program. See. Okay. I should ask it here, right? That question. So find the largest element of a structure according to its order instance. So we have order instance. Define a partial function. Why it's a partial function first? Which defines the maximum of non-empty array of integers. If it's not empty, it cannot be partial, right? Is that right? I feel that this how do I say that enunciado em português? Enunciado. Quest statement. Is that right? With the question statement string, right? Test out your function in PSCI using a safe partial. Use maximum function for data portable. I'm seeing a little instability here. Seems to be okay. So, the maximum function here returns a maybe value. It means that it's not partial, correct? And because the maybe type returns nothing or just construct. It has a nothing and just value. It has no values, right? So from for a given photoable, it can return the value. Okay, I can turn that in a partial function, just in handle the just case, right? I feel that's possible. So let's do that. First, must move this comment part here to our assertion. So we have this unsafe maximum here, which calls unsafe maximum pattern array and calls that unsafe partial function, which takes up a partial thing and yeah, and return that thing. Yeah, I missed that unsafe partial here. To call a partial function to allow the runtime to trigger, right? I need to call the unsafe partial function. Maybe in Haskell there is no such unsafe partial. Let's see that. Yeah, maybe something like that. So there is no such unsafe maximum, right? We are importing my solutions here. And we can declare the function right here. It takes let's see here. Yes, this signature here. So we constrain about being a partial function, so it's allowed us to don't handle all possible scenarios, and it receives array of int. Right, I'm just copying that and returns an int, and the implementation of that would be something like calling maximum. Let's see the maximum function signature. First I will import that from Foldable, right? Yes, Foldable. So let's just check here. The function signature is is that. So it receives a foldable thing, right? And we know that array is foldable because we have seen the instance of that in type class. So we take that foldable array with int values, and we return the maybe, and we can just return that. Should we not take one value of that, like the just value? Let's save and see if it runs. I will run the test here in watch mode. Yeah, we cannot maybe match maybe int with just with int, right? So I need to somehow transform, take the just value of that thing. I know that is a just function from maybe package. Let's see here. Probably takes we have maybe here, right? Probably in Prelude. Yes, in Prelude we have maybe. How do I take? Yes, we have this. Takes the full value and the maybe value. If maybe value is nothing, the full value is returned. Otherwise, this is not what I want to use. No. So we have a situation where we have this maximal function call, which returns a maybe value, and yeah, I need to like hack something here to do that, or I can like pattern match that. Yeah, I can do that. For example, we can, hey, if you have just array, right? Call maximum with that array. Yeah, we can do that. We just need to know who is just. To do that, we need to import maybe. Data maybe. So let's do that. Import maybe. Maybe and its constructors. Ah, of course. The problem is here is that I'm matching this thing here, but actually I need to match this thing here. So the right way to do that is just to use case off, and if it's just array, returns the array, right? No. If it's just a number, it's actually the max number, right? Return the max value. There is another way to do that. Let me see here. A more cleaner way. I have a value and I need to take the just value of that. Yeah, that is not another way to do that, right? Maybe we type hinting.
Man, it's the farmer man. I go from Skip's
Let's see here in the Jordan reference maybe for maybe type class or for pattern mating. What you want to see is pattern mating or how to. I feel that the only way to do that is with pattern mating. Function queuing. Letting case expression off. Yeah, I don't see another. Let's see algebraic data types. Function and data with high kind of types. Let's see that here. Probably not. It's algebraic data type. Type class kind signatures. No. Let's look for here. Algebraic. Algebraic. The primordial composing types algebraically. Interesting. A deep thing, right? My back. I need to take a break. Actually, it's not that what I'm looking for. I was looking for where it's the data constructors, right? Let's search for constructor here. Smart contractors. I may want to write that design patterns after I finish that book. Let's see, keyword data. We have type constructor, data constructor. Yeah, I need to take that break. I'll be back soon. Stay tuned. Hey, I'm back. I was doing exercise for my back. It's right to say back. Every time I say, it's my back. I say back, yeah, that's right. I was thinking about adding my webcam here in my notebook. I did not because my webcam is so trash, but I feel that having a trash can is better than nothing. Let's try to do that here in my OBS. How do I do that? Screen capture, video capture, right? Let's try to do that here. Yeah, my bedroom is that is too lighty, and I have a window behind me that just makes the working of the camera, the job of the camera worse. If I can somehow adjust that illumination. One day I'll fix that, but for now, exposure. Okay, let's just keep that way for now. So I'll put that here. But I should have put that first. In this screen, I need to remove that from that screen and add another screen. My code screen. Can I paste that? Should do that again. And I need to select the camera. I cannot change the that flashing. I just keep that default because come on, you be a bit now. Can I move that? I need to move that here, paste reference. I should put that here. Yeah, it's good here. And I can copy that and paste in browser. So yeah, now you can see me. Not so good because see if I move that right here. Yeah, let's keep that way. I should change that to like I need to zoom a little here, right? Can I do that here? Let's see, transform. Done is better than perfect. Okay, we are trying to solve this first exercise, and we'll save maximum, right? And that let me see a little stability here. Let's see. Okay. So unsafe maximum, what we're doing, we are actually testing the case of returning maximum array here. So we take the maximum value and return that. Let's save that to see if it works. No value. Okay, yeah, I need to pass that value. Can I do like something composing thing right here? Can like let's see, I can compose maximum. I don't have two functions here. Yeah, let's keep that way for now. Let's think about composing this thing here. Okay, to pass it, let's check if there is another test here. No. So I'll just commit that. Save. Chapter 6. And save. Solution. Okay. Next exercise. The action class is a multi-parameter type class which defines an action of one type or another. So the action class is a multi-parameter type class which defines an action of one type or another. Which defines an action. What do you mean about the actions like a function? The action class is a multi-parameter type class. Okay, it has two parameters, right? My string is very unstable now. Let's refresh that. The action class is a multi-parameter type class which defines an action of one type or another. Which defines an action of one type or another. So what we have here, we have a monoid type class, which means that m thing here has an empty value and can be appended. And we have an a thing here, right? And we have a function called a member called act, which receives that monoid and also receives that a thing and returns another a thing. An action is a function which describes how monoidal values are used to determine how to modify a value of another type. An action is a function which describes how monoidal values are used to determine how to modify the value of another type. There are two laws for the action type class. Act mempty a is equal to a, right? And act m1 append with m2 and a is equal to act over m1 and passing the resulting value of act m2 and a. Applying an empty action is a no b, right? And applying two actions in sequence is the same as applying the actions combined, right? That is, actions respect the operations defined by the monoid class. For example, actions respect the operations defined by the monoid class. Actions respect the operation defined by the monoid class.
Does she know that?
For example, the natural numbers from monoid under multiplication. We have a type multiply, which has multiply constructor with the int value. We have an instance semi-group multiply with instance semi-group class. That means this multiply thing is appendable, right? Because semi-group has appendable member. Let's just check here. Yes, concatenation. So same group has is appendable. So we have an instance for same group that passing that multiply type. So I can like append int together. Actually not int, right? Actually we can append multiply things together. Here's the instance implementation, taking a multiply number and another multiply number and build another multiply from those values. We have an instance monoid multiply, which is a monoid type class instance. That means that that multiply thing has an empty value. In this case is 1, right? Write an instance which implements this action. So we have to write that instance here, action multiply int. Write an instance between this action, so we have this type class here. Action, right? This way we can like declare those laws here. The laws listed above, so we have two laws here. Like I can call action passing two numbers. I can call action passing two numbers. Well, let's try to do that. I'm not understanding why this is used, but it doesn't matter, right? It doesn't matter. Let's just do the exercise. So first I will move comment block here to the next test, action multiply int. So here and I say M1 is multiply 3 and M2 is multiply 4 and A is 5. So calling act empty multiply and A value, which is 5, right, should return 5. That's the first assertion. And the second assertion is gonna be, I will move just to the next one to like because we cannot just implement the thing properly, right? Actually it was better if this has come first, but it's okay. We have some concrete here, but I don't know if it means something related to instance of that type class. So because of that, I'll just assert these two tests here first together, right? And of course we want it will fail. Let's see where, so we can fix that. There is no such multiply, so let's do that. First we need to copy that code right here. Should not the test implement that multiply thing by themselves? No. It's to us to do that. Okay, let's do that. Now we have multiply. I need to cough. I'm thinking about getting a cough. I really need a cough. So multiply no value act. Yes, we need to instance that action type class, right? So the signature must be that one according to the exercise. So with that in place, we're gonna see no class action. Sure, let's do that. I will copy the action class here and paste there. So now we have an action type class, constraint about having an instance from a monoid type class. And we have that act, remember, right? Which must be implemented. And that's gonna be the error now. Following type class member have not been implemented, acted, act. So let's do that. Acting of, how do I do that? I don't even know. Act takes a monoid. And we need to obey those laws here. And we need to resolve that value to that value here, 5, right? So the thing is, if I have any empty thing, empty thing of multiply, I will not specify anything. Let's see what's gonna happen. So if I have something, what I did, I just jumped it. So if I have an instance of something called mm and a, I will return just the a thing, right? Then let's save that. No type class instance was found for monoid multiply. So yeah, we are constrained about having a monoid. Let's see here. We have an action type class which receives the multiply thing here. And it's constrained about having monoid for that multiply thing. So the missing part here is this thing here. Let's copy and paste that. Let's do that here together with multiply. So I'm just copying and pasting. Now no type class instance was found for same group. So let's copy that here, right? Now what's gonna be the problem? No, there is a problem. Warning here. No empty was introduced but no use. Okay. So I can like just skip that. If it's not used, right? Alright. passed. Okay. Don't know why, but it passed. So let's do the last assertion. I'm not feeling so confident about those tests here. Yeah, of course, I was expecting that. So let's try to understand what's happening here. First, the error, right? Concrete failed concrete because here we have this action multiplying concrete. Expected one of one 518 and got 5. Yes, because it's just returned the second value of that thing. So let's try to understand what's happening here inside. We are asserting we have this expect one of, which is array of those values here. We have a got thing is the act of m1, which is the multiply 3 with the a thing, which is the 5 number, 5 int here. This is a int, right? In PureScript. So it was expected that we are asserting here because let's see here, the assert function received a string giving a value reason, which is probably the string, right? A boolean, either subset if boolean is true or fail if boolean is false. So here is just the error message, and here is actually the assertion, and this thing here is the same as call the result of this function here, which is a function over the result of this thing here. And the result of this thing here is the result of calling element passing. What is element, right? Element is a function that takes array and returns a boolean, and that function constraint about that a thing inside of the array can be like matched together to check if they are equal, right? That is the equal type class constraint here. So it is receiving an array and it must return a boolean. Okay, so it just check if the got thing actually got thing is that a thing, which in our case let's see here that in our case a thing is gonna be int, because we are in instance that for multiply and int. So in our case got actually is a result of calling that action, and as that action return the a thing, and the a thing is that a thing here, it's a int number. So this got thing here just returns a int value, and we are checking that int value if it's equal to what? Yeah, this a thing here is the number, right? The got number, and the array here is array of that int numbers expected one off. So the thing is happening here is that assertion here is expecting that got should be one of those values here. So got is 5, but it expected one of those values here. So got needing to be 1, this number or this number. In this case, probably the law missing here is that one, right? In this case, we are actually receive something which must be used. That thing which is being received, the active thing here is that m1 thing which is multiply 3. So if I have something something called multiply with a given number and something else, right, I should do that before this thing here, should not because I need to first match that. If that not match, we can like do that, right? Like in a catch-all thing. So receiving a multiply number and int number here, right? But the thing here is that the thing that I must constrain here is about that thing being appendable, because it must be a result of append those things together. What can I just assert the result of that expression? If I do this thing here, I know that multiply is appendable because it has same group instance, right? I can of course do something like, hey, yeah, it's already there here because because action is constrained about having an instance for monoid. It means that that thing here can be appended, right? Can be appended like this. So yeah, I don't need to assert that there. And of course I can just copy and paste that here. Let's see here. I can do this implementation here. Changing. I can like recursive call act over the n value and the A thing, right? Actual mini one, XGM2. Actual, let's see here. It must take in a monoid uh, unvalue. In this case, int. It must return an int number. So yes, I can of course call this recursively, and I need to pass that in. And yes, the thing that I need to do here, the second number is calling it's not this thing here. I feel that I should look for the int thing here, right? This is gonna be an infinite loop. Let's save that to see what happens. I feel that I will just no type class instance was found for int, calling with int and int. Okay, because n is actually an int value. I know that so the thing is, I cannot extract the number here. I need to just append them together. Because here we have the m thing. And if I do something like that, let's see, I'm obeying to the function signature. I can like concatenate this m thing with this a thing. Right, makes sense. What is missing here? I don't know. Alright. So let's try to recap here. The action class is a multi-parameter type class which defines an action of one type on another. Okay, of one type on another. In this case, it's gonna be the multiply type over the int type. An action is a function which describes how monoidal values are used to determine how to modify how monoidal values are used to determine how to modify a value of another type. An action is a function which describes how monoidal values are used to determine how to modify a value of another type. An action is a function. This part is an action is a function which describes how monoidal values. So what are monoidal values? Monoidal values are like values from type which can be empty. So those kind of values are used to determine how to modify a value of another type. There are two laws for the action type class, like receiving the actually call action over 2 the result of two m things, right? Which is this thing here append together as the m thing, and the a thing, which is this thing here, which is in our case an int number, is gonna be the calling of acting that m1 thing and calling that act of that m2 thing of the same a. and that thing here is the A of this thing here. Applying the empty action is a known operation, and applying the two actions in sequence, it is the same as applying the actions combined. That is, actions respect the operations defined by the monoid class. Actions respect the operations defined by the monoid class. For example, the natural numbers from monoid multiplication write an instance which implements this action. So the thing that I know is that I need to use append somehow. Because we know that act is calling when passing when calling act with empty value and 5 is going to return just 5 because the empty of multiply is 1, and calling act with the result of calling, yeah, it's the law, right? It's that law here. So calling this thing here append together with the A thing and this thing here, let's see the values, right? This thing here in this case is gonna be 3 times 4, which is 11, 12, with an A gonna be 5, 12 and 5. So the result of that is gonna be calling act with the 3, and the A thing is gonna be calling the 4 thing multiplied by 5. 4. Let's see here. So here we have like here we have like something like act, this thing here and 5, and here we have something like act don't know what your value is gonna be that. Act M1, which is 3, with act M2, which is 4, and A, which is 5. So this is gonna be like I don't know. What I know is that this thing here is equal to this thing here. I feel that I'm seeing something important here. I know this thing here is multiplication, right? In this case, if I'm going to apply that, where did this 4 come from? Action intent. Why is this happening here? No type class instance. Okay, could not find multiply with type int. While trying to mesh. Yeah, so I need to just take the value here. Like multiply and do something like that. No type class instance was found for same group int. Yeah, I cannot just do that. This thing here must be... I see that. So to do that thing here, actually the thing that I need to do is build an M2 thing, right? To solve that thing. So to do that, I just do that M thing append with, because remember we are obeying to those law here, and the M2 thing is gonna be multiply, right? A. So now I have two multiply values. Is that right? Could not match type int with type multiply while checking expression as type t0. While check that expression A has type t0 in value declaration. I need to hint that this thing here is an int value, right? Can I do something like, hey, this thing here is int A? Should do something like that. There is no such int. Yeah, there is no such int thing here. In the action thing here, actually I am certain that A is int, right? So yeah, that is not a problem here. I'm hungry. Oh yeah, I need to return int here, right? How do I do that? How extract any number? Because act here must return a thing, right? So somehow I need to extract. I can do something like this. Hey, this saint. Can do something like that.
Well, now, that was quite a speech.
Oh, I'm sorry if I bored you.
Cannot do that.
Oh, no, quite the opposite.
How do I do that? I must return here int. How do I return int from another type? Calling action that thing, right? So the thing that I need to do here is call act recursively. The m thing is that thing here. Actually, this is the a thing. No, the m thing, yes. And the a thing is gonna be a number. Which number? Which number is gonna be a? Because act was made to like extract the number of that monoid, right? No. Is that right? Let's say I have a m1 and I want to concatenate m1 with the multiply a. And I want to do that like yeah, I can do something like for a thing I will call act of empty, empty of multiply right, and the second value is for what? For given monoid, I will append the monoid with the inverse operation, so I will turn back the a value into multiply, so it can be appended together. That's right, but I need to return int value for that. So to do that, I must call act I probably would do something like 1 here. Here, takes 1. But not feel to be right. Because I have empty here. I should use that. Let's try to see what happens. A case express contains unachievable case. So yeah, I need actually here a set that's gonna be a empty value. How do I assert that's gonna be a empty value here? I should do something like that. Multiply. A case operation contains unreachable case. I want to match that thing here. How do I do that? Can I like constrain that? I would do something like that. I mean, if the empty thing is equal to this thing here, so you return that. Otherwise, something like that. Is that right? I'm liking, hey, test if empty is equal to empty here. No type class instance was found for equal multiply. Let's search here in the type class syntax or pattern matching syntax. Pattern matching. Let's first try to look in this chapter here, if we did that before. How do I pattern against a value? Actually, it's not against. Yes, it's a value, right? I have that empty value. So I don't need to do that thing here. And let's call this M1 the same way. M1 to keep things cleaner. Okay. Still there is no such. Yeah, I can use that like empty, right? I'm using the same name here. This means that this means a value actually, right? MEM to introduce but not use. No, it's not the case. I'm actually using the value multiply 1. So I need to do something like that. Look at how I use a value here. That's strange, right? We have a recursive loop here, infinite loop. I'll take a little break. Back soon. Okay, guys. Yeah, there is such a feeling up here. I'm not a... I will do something, so I will try to ask here in the community. How do I... Of, there is no... I look at that here. Not found the response. I look at that. Let's see here. MM. Let's see this. Let's look in here. We have MMs, right? Is the identity value? What is this? What I'm looking for? I'm looking for an example of referencing that MMC. Let's copy and paste that. I'll try to look that in Google. Sure. How do I reference statement? Pattern. If I have something like Yes, you could use a chord and equal. If you think you will also have equal instance. Or you could just always wrap and do the multiplication. It's pretty fast. So in this zoom, that is not native way to do that, and we should use the thing that I did before. Like, let's see here in my history, right? Something like that. But to do that, we need to have an equal instance from that, right? Or you could just always wrap and do the multiplication. That's probably fastest since there is no branch. Yeah, I can just take the value and multiply them. But in the operation that I'm doing, I need to append them together. Right? You cannot just do that, because the append operation is inside here. Yeah, that is the only possible way. So let's try to do that. We have here the scenario where m empty is equal to m1 actually is equal to m empty, right? And otherwise, this scenario here, I need to instance. Let's see here. I need to instance multiply equal. Yeah, so let's do that here. Instance equal multiply. Equal multiply where equal multiply number. I can like derive that, right? Let's just derive that. Okay, so now I can and of course I can, instead of no, I cannot do that. I cannot call act with yeah, it just needs to be 1. So that is a problem in here. Maximum call stock, we are calling this, it's calling m1 and the a value. Again, somehow it must the recursive call, it must let's see, this active function here must reach to some point where m empty is empty, and that's never happening. It's never happening here. Why I'm multiplying them together, and that sums up to infinity. So I would never achieve that point here do I solve that? Uh, yeah, I don't know how to solve that. I will do something, so I will finish for today, and tomorrow we back to this. I will keep a comment here to remember where we are. We should somehow achieve a scenario where this line is called. I'll move that to where next line. Let's move that where the before line scale is called. To finish the recursing call. That's a thoughtful one. I think it's because the I don't know the way this is working here. So tomorrow probably I'll be back to try to solve this one. Let's push this here. So someone is willing to try this code here. It's in chip. This link. I'll copy and paste that in the chat. So see you again tomorrow. Bye bye.